Hello, hi, welcome to today's presentation. Today I'm going to show you how to make a polynomial regression model in R. We will go through it step by step. I'll show you how to create a model and how to predict with that model, how to test the performance of the model, and how to plot the fitted model using R. I will be using RStudio and in R Markdown. We are going to start by loading libraries that we need to make this model. We will need the library, tidyverse library for data manipulation. The tidyverse library is library, and we will also need the caret library for the functions that we need in creating our model and predicting the data. So we need these two libraries for our model, and let's load these libraries. Now that we have our libraries loaded, we need also the dataset to use. Let's load the dataset. And in today's presentation, I will also use the same dataset we used in my previous video when I was presenting about simple linear regression and multiple regression models. And that dataset, it is the Boston dataset. Let's load it. It's the data. We are going to load the Boston dataset, and this dataset can be found from either the IRS library or from the mass library. So we have to specify the package where to get that dataset. This dataset can be found, for instance, from the mass library. And then let's go ahead and load this dataset. Yeah, here we go. We have our dataset Boston loaded. Here, if you want to view it, here it is. And for those who didn't see my videos, if you want to view this dataset, for instance, we can use the still function Boston. And if you use this function, you can have a general overview of Boston. Yeah, a general overview of our data set here. So we have a data set with 14 variables and 506 observations. And we will not use all of these variables in today's presentation. Today's presentation, I'm going to use this made variable as a response variable, and we will use this start variable as the predictor. So now that we have our dataset loaded, let's go ahead and split this dataset into two datasets. One for training our model and the other one for testing the model that we will be fitting. So we have first to choose indexes for our training data, and those indexes, let me call it train index, train.index, and these indexes should be taken from, let's say, from our response variable indexes, and the response variable is the Boston medv, and from this Boston medv, we need to partition all the 506 indexes into two parts. Let's say that the 80% of the data will be the training data, and the remaining 20% to be a testing data set. So we have to split this data set into two parts, and to do so we use the create data partition function. Create data partition this function. And how do we partition our data? We have to give a probability of partition, and we want that 8% will be in the training data set, then the probability should be 0.8. Yeah, so let's say list false, list equal false, so that our indexes will be taken randomly. Since we will be having random sampling here, let's set a seed so that the sampling will not change anytime we run our code. Let's set the seed to be at least, for instance, this seed. Yes, we set a seed and we choose our indexes to use for the training data set, and then let's create a training data set. I call it train.data, and then the train.data will be a part of the Boston data set, and the part will contain the rows, these rows in the train indexes. Then the rows will be the train dot indexes and all columns. This is the train data set here. We have it here. Yeah, this will be the training data set, and then the remaining part will be the test data set. Let me call it the test.data. And this will be the remaining part from the Boston data set. Then Boston, and we subtract this training data set. How do we do it? Then we use minus the train indexes that we have set there. Train dot index and all the columns. So this will be the test data set. Yes, now that we have our data set split into two data sets, let's go ahead and build our model. Let me call it model, and this should be a linear model, then RM function, and the response variable is the med v, and we need the formula. And in the formula we use the function poly because we want to construct a polynomial model. And the polynomial model, we need the predictor, the predicting variable. The predictor, I want that we use the RStat variable, and I want that we make a polynomial of 5 degrees, and let's say rho equals rho true, and we need the data set, the data being our training data set, then train dot data. Yes, that's how we make a polynomial model in R. Yes, now that we have our model created, let's see the summary statistics of our model. For instance, the summary, our model here, and then from the summary outputs, we can get much information about our model. Make it bigger. Yeah. Yes, here you go, and you can read many different things from these summary statistics. We have the coefficients, and the one sample test for the coefficients, and their corresponding p-values in the last column here, this column, and you may have the residual error here. The residual error here, and you may have the coefficient of determination r squared and the adjusted coefficients of the determination. Yes, many things can be read from the summary statistics. Yeah, since we have our model now here, we can go ahead and make predictions using our model. And to predict with this created model, we have to use this test data that we have reserved for testing our model. And how do we make predictions? Let me call it predictions. And how do we make the predictions? We have to predict with our model, the model that we have created. And how do we predict? We have our model and we use the function predict. And the function predict will take our data sets that we have reserved, then the test dot data here, and we get our predictions here. Yes, so from the predictions we can check the performance of our model, for instance using the root mean square error and the r squared, the coefficient. How do we extract these performance indicators from our predictions? For instance, the root mean squared error can be computed by using the function root mean square error, this RMSE function, and this RMSE function will take the predictions, then predictions, I have called it predictions, and it will also take the values that we want to predict with. So we want to predict with the test data, and which variable are we predicting is the med variable. Yeah, so we want to predict with these variables and using the prediction. So from this command we will get the root mean square error of our model. So, and if I print it, I will get print root mean square error. Then here is the value. This is the mean square error for our model, root mean square error. And if you want the coefficient of determination, the r squared, then you will use r squared. This r squared will be equal to r squared function, and it will also take the predictions, and the variable that you want to predict with is the test data set from our med variable, med. So then with this command you will get the r squared coefficient. And if you want to print it, print r squared, and if I print it here, then you will get it down here, 0.68. Yeah, so the other thing that we can do here is to plot our model and the data set and see its visualization, and we can do it by using the ggplot function from the ggplot2 library. And how do we do it? We can just do it like this: ggplot, and we need the data set. Our data set, we use the training data set, train.data, and the in the is function we need the value, the predictor. The predictor is, in our case, was a start variable, and the response variable is the med variable. And what else? Then we have to add the J1 point, yeah, and we had to add the start smooth. And what method do we want to use? We want methods, and we are using the linear model, and the formula that we are using is the polynomial formula, and the formula that we are using is y response variable equal to the pole x with degree 5 degrees, and rho equals true. Yes, so if we do Like this, we will be plotting our data, these data points, a start variable on the x-axis and the med v on the y-axis. Then we add the prediction and they are 95% confidence interval. Yeah, so like this we get this plot here. So here I go. Yeah, so this is our visualization. We have here at the x-axis our predictor and the response variable and the predicted model in blue and the confidence band 95% confidence limit of our prediction. And if you want, you can add the titles and the regent, everything. Yeah, so guys, now that's it. We know how to create a polynomial model in RStudio, and we have seen how to split a dataset into two datasets, the training dataset and the test dataset, build the model using the training dataset, and make predictions using the test dataset, test the performance of our predictions, and plot your built model. Thank you for watching and learning with me, and I hope to see you the next day. Thank you. Bye.